Hey guys, I'm here again with a wonderful video, and this one is a product rule under differential calculus. All right, now I'm going to teach you using an example. So let's have an example. Let's say we are asked to actually differentiate or find the derivative of y is equals to x squared into x minus 1 all raised to power minus 2. Now, how do we now work it out? Now, but remember we told that it is product rule. What is the special thing about product rule? What is it saying? Now, this is why it is product rule. The value of y depends on this and actually depends on this, and you are multiplying, so we call it product rule. Now this is what you need to do, okay, in solving this. Now you will have this. You can say let your u be equals to x squared, then of course your v is equals to x minus 1, then okay, raised to power minus 2. Now the way to work it out is this. All right, dy by dx in this kind of setup is going to be v du by dx plus u dv by dx. Basically what you are going to be doing here is that since from between the two products anyone will keep in the first instance will differentiate the order, then we'll now have a reverse, okay, in the second instance. That is what we are going to do. So let's try and do it now to see. All right, so since my u is that, my v, now I'm going to keep my v. All right, my v is x minus 1 all raised to power minus 2, so I have it here. Then times the differential of u, which is 2x. Differential of x squared is 2x. Now plus I'm going to keep my u now, which is x squared. Good. Now this is where we have a little bit a little work to do. Now you watch, if you've watched my former video, you understand that there is a short way to do this, which I'm going to do now. Now if I have x minus 1 all raised to power minus 2, we should differentiate. This will come down to be minus 2. I will assume this to be just an entity, so we have x minus 1. Then of course this is minus 2. Of course, you know the power is supposed to reduce by 1, so we subtract 1. Then times the differential of whatever is inside here, and the differential of x is 1. So basically everything then turns to minus 2 into x minus 1 all raised to power minus 3. All right, so we've gotten that. So here we are going to have minus 2 then into x minus 1 there is power minus 3. I have actually differentiated it. Now we've gotten our dy by dx. The next set of things we are going to be doing will be just simple simplification. So we continue now. Dy by dx will be equals to, now we have this, which is going to be 2x. Now recall, using indices, this is going to be 1 all over x minus 1 all squared. Okay, so take note. Then plus okay, now this is actually, let me just put it this way, it's going to be minus 2x squared, right? Then you are going to have 1 all over x minus 1 raised to power 3. Remember the indices thing that I just mentioned. So this is going to be 2x all over x minus 1 all raised to power 2. Then I have minus 2x squared all over x minus 1 all raised to power 3. Now I wouldn't want to leave my work like this, so I'm going to find the LCM. Now this is the LCM now. The LCM is x minus 1 all raised to power 3. Now when we divide, when we say x minus 1 raised to power 3 divided by x minus 1 raised to power 2, of course we know it is x minus 1, but is it then times 2x? That's simple fraction, okay? And this is going to be minus 2x squared. Now all we have, when we expand the bracket, we are going to have 2x squared, okay, then minus 2x. I have minus 2x squared all over x minus 1 all raised to power 3. All right, so we can see that this will take off this, and my dy by dx will be equals to minus 2x all over x minus 1 all raised to power 3. Now this is a very valid answer. So it depends on how the answer is being presented. I can decide to have it in the form of the question we're given. Look at the form. Okay, so I can decide to have it as minus 2x into x minus 1 all raised to power minus 3. I can decide to have it this way. So either way, you can actually have your answer. So either this or that as your answer. So that is a very good question. Keep watching and keep learning.